these properties, let's discuss properties of group. Let me tell you one very interesting thing about GATE exam and group theory. So if you check all the previous year GATE questions from groups, then you will find one thing, that in the GATE exam they are defining something new. There are many questions in which they are defining something new. Okay, they will define something and then they will ask you a question. So in the group theory, if you want to solve a GATE exam question, then proofs are very important. Okay, so this is what I'm saying. For groups, you can notice proofs are very important, but the interesting thing is they are very easy also, and they have same template. For GATE level, all the proof in groups, in group theory, all the proofs have same template. And what is that? Just apply the definition. Apply the definition of inverse element, apply the definition of identity element, just apply the definition. Did you check? In the last class, we have done 2-3 proof, and for all of them, we only applied the definition. Okay, very simple. So in the GATE PYQ, when you solve the GATE PYQ, at that time you will find this, that proofs are extremely important in group theory. Okay, and these are very easy. And these two things you have to follow. If you almost all the proofs need two things, almost all of them, just apply the definition. Also multiply both sides by inverse. That's it. Okay. If you do these two things, then almost 99% of the proof for GATE exam, almost 99% proofs are done. Okay, so this is what we are going to do now. Multiply both sides by inverse and also apply the definition. These are the two things. This is the template. Now let's see the first thing. In a group, can I say identity element is unique? In a group, can I say identity element is unique? Yes, I told you identity element is always at most unique. If there is identity element, then it is always unique in any structure. For all structure, if we have identity element, then it is always unique. So for group also, this will always be unique, because in a group you should have identity element, and the identity element will always be unique. Why? What is the reason? See, interesting thing. Just apply the definition of identity element. Assume that E, E dash are identity element. Assume these are identity element. If you assume these are identity element, then just apply the definition. So E is the identity element. What it means? So just apply the definition. Because E is the identity element, what this means? So what should happen here? E is the identity element. Then what should happen here? E is the identity element. Then I should get E dash. Because E is the identity element, so I should get E dash. Because E is the identity element. And because E dash is the identity element, so what should I get? Because E dash is the identity element, so what should I get? I should get E. Okay. So because of this, I will get this. And because of this, I will get this. Now you can just check what we have. So what we have? So we have E star E dash is equal to E, and this is equal to E dash. What this means? They are same. So you can never have more than one identity element. So identity element will be unique. This is a very simple proof, very simple proof. Okay, just apply the definition, nothing else. Here I am applying the definition that E is the identity element. Here I am applying the definition that E dash is the identity element. That's it. This is your proof. Okay. Now the next proof can you do? Every element has unique inverse. This proof can you do? Prove. Try this. This is very interesting. Prove that in a group, I am talking about a group. And you know in a group what properties we have. In a group we have identity element, inverse element. But I am saying in a group, every element has unique inverse. Prove it. Just try this. So how will you prove? The proof is very simple. Just assume that some element has more than one inverse. Okay, so this is the proof. The proof by contradiction. Just apply the proof by contradiction. Very simple. Assume that A has two inverse. Assume that A has two inverse. Okay, just assume, because this is saying prove that in a group every element has a unique inverse. So just assume that A has two inverse. Assume A has two inverse. Okay, A has two inverses. What are these? B, C. Let's assume. Okay, so let's assume you have two inverse B, C. Then what it means? Anyone? Apply the definition. I am saying A inverse is B comma C. A inverse is B, A inverse is C. So what will happen? So what will happen? Because B is the inverse, so A star B should be equal to E. Because B is the inverse. So what should happen? That A star B, this should be equal to E. And because C is the inverse, so A star C, this should be equal to E. This should be equal to E. From this, what it means, what I got. See, remember, because B is the inverse, so this I got because B is the inverse. And this I got because A inverse is C. Now it means that both are same. A star B is equal to A star C. Because this is also E. This is also E. So it means this is what I got. Now what I will do? Now let me multiply by A inverse. Let me multiply by A inverse on the both sides. See, this thing is same as this thing. Then if I multiply by A inverse, then this will be same, right? Agree? If I multiply by A inverse, because two things are same, then if I multiply by A inverse, it will be same. Very simple thing. Because this thing and this thing are same. Okay, so if I multiply both sides by A inverse on the LHS, then they will be same. Because this and this are same. It's like this. It is something like this, like A inverse D is equal to A inverse D. If I call it D, let's call it D. Then I can say A inverse D equal to A inverse D. Because if this is D, this is also D. So I can say A inverse D equal to A inverse D, right? Agree? So I can multiply both of them because they are same. Because this and this, because they are same. So I can multiply both of them here by A inverse. This is what I can do. Okay. So now what this, because associative, group is associative, right? So this is what I have. A inverse star A star B is equal to A inverse star A star C. And you know that group is associative. You already know that group is associative. Because group is associative, so I can write like this. Because group is associative, so I can write like this. Agree? I am not using anything else. I am only using the definition of group. So I can say that because group is associative, so I can say, okay, and what this means? This means E. E star B is equal to E star C. And what is E star B? That means B. So from here I got B equal to C. So if you have two inverse, then they will be same. Agree or not? Very simple. See, one thing you notice, I did not do anything. Only I'm using the definition. I'm using that that group is associative. This is what I'm using. Group is associative. So this will be same as this because group is associative. So I can do this. So I'm only using the definition of group. Nothing else I'm using. You have a group. In this group, you can, okay, every element has unique inverse, because if you assume that A has two inverse, then we can prove that they will be same. Very simple. Another property, let's prove this left cancellation. Group has left cancellation. Let's prove this. Prove that group has left cancellation property. Prove that group has left cancellation property. Prove that group has left cancellation property. Very simple. Very simple. Remember this. Okay, just read this one. Almost all the proof need two things. Almost everything that we will prove, almost all the proof, they will need two things. Either you apply the definition, like the definition of identity element, definition of inverse element, definition of associativity, or you multiply both sides by inverse. Only two things you need. Nothing else is needed. Only two things. Now let's prove that group has left cancellation property. What it means? It means that if A star B is equal to A star C, then we have to prove that B equal to C. This is what we have to prove. Okay, this is what we have to prove. This is called left cancellation property. This is known as left cancellation property. Because what we are doing, we are cancelling A. This is called left cancellation property. So this is what we have to prove. So what I will do, very simple, extremely simple. Just assume, just let's assume A star B equal to A star C. Then what I will do, two things are same. It's like this is D. If this is D, this is also D, right? If this is D, this is also D. So are they same? Tell me, are they same? These two, are they same? Yes, of course they are same, right? Yes, of course they are same. Okay, so that's the idea. So this is the idea. So I can finally, I can multiply with inverse. I can multiply by A inverse. Now what should I do? Now what should I do? Remember, group is associative. Remember, group is associative. You already know that group is associative. Because group is associative, so we will get, this is what I can write. I can write like this because group is associative. Because group is associative, so I can write like this. Now very simple. Now this is E. This is also E. What is E star B? What is E star B? E star B, that is B. And what is E star C? That is C. So finally what I got? I got B equal to C. Is this hard? Is this proof hard? Only using the definition, only multiplying with A inverse. I am telling you, again I am telling you, in the GATE exam, when you solve the previous year GATE exam questions, you will notice that in many questions, proof is important. You will find it out. And you can notice that proof is very easy. Two things you have to do: apply the definition and multiply with inverse on both sides. So you can notice that a group has left cancellation property. This is the proof, yes or no? So we started here. From here we started and we found that B equal to C. It means we can do the left cancellation. That's the point. So if this is true, then B equal to C. Similarly, group has right cancellation property. We can also say that group has a right cancellation property. And the same proof will work. So if you have this, for example, if you have A star B is equal to C star B, then what to do? Then what to do? Multiply with B inverse on both sides, on right side. Two things are same. If these two things are same, then I multiply like this. Like this I can multiply. On right, I can multiply on right. Because this thing and this thing are same. Two things are same. So I can multiply with B inverse. Now what? Now you already know that this is commutative. So finally I can say this will be A star E is equal to C star E. And what this means? This simply means A equal to C. This simply means A equal to C. Means we have right cancellation. We can do right cancellation. Okay. So in a group we can do left cancellation. In a group we can do right cancellation. Remember this point always. In group we can do this. In group we can do, if A star B is equal to A star C, then it means B equal to C, because you can do left cancellation. Similarly, if A star B is equal to C star B, then you can do right cancellation. Then it means A equal to C. But not that, but don't do this. This you don't do. Now here you don't do this. Please don't do this. Because group is not commutative. This you cannot do. But this does not imply that A equal to C. So you can do left cancellation, you can do right cancellation, you can do, but you can't do that this right and this left. This right and its left. You can't do this because group is not commutative. If group is commutative, you can do this. In abelian group, you can do this. Yes. In abelian group, you can do this. If you have abelian group, then no problem. Then this is also clear. This is also correct. And this also you can do because it is abelian group. Because it is abelian group, so this is same as C star B. So this is same as C star B because it is abelian group. Okay, so you can write this as C star B, and now you can do the right cancellation. So finally I can say that A equal to C. So in abelian group you can do. In a group you can't do. So these are the cancellation laws for the group. So all these things we have seen. Now some interest like left cancellation law we have seen, right cancellation law we have seen, and inverse of, okay, this we have already seen. A inverse whole inverse, that will be what? A inverse whole inverse, that will be A. That will be A, because you can notice, if you already know that if A equal to B inverse, if and only if B equal to A inverse, by the definition of inverse, in the last class we have seen this. If A is the inverse of B, then B will be the inverse of A. This we have seen in the last class, already done in the last class. Okay. And what about this one? How to prove this? You have a group. Let's assume you have a group. Then can I say this? AB inverse will be B inverse A inverse. Then prove. This is what we need to do. AB inverse will be B inverse A inverse. So tell me, how will you do this? AB inverse will be B inverse A inverse. This is what we need to prove. What is the idea? What do you think? See, the idea is very simple. What do you think? What should I do? The question is talking about inverse of AB, right? Remember what this AB means? This AB simply means A star B. This AB simply means A star B. So the question is talking about AB whole inverse, means very simple. So just apply the definition of AB inverse. So you have AB, let's assume its inverse. Let's assume its inverse is Y. Let's assume its inverse is Y. Okay, very simple. Because the question is talking about AB inverse, inverse of AB. So let's assume that inverse, let's assume AB inverse is Y. Now what should I do? Now apply the definition. What it means? Now what this means, can anyone tell me? If AB inverse is Y, then it means ABY is equal to E. ABY is equal to E, correct? Now what to do? Now we need to find Y, because actually we need to find Y. Basically we need to find Y. This is what we need to find, because the question is saying that AB inverse, and this is what we are calling it Y. So I can say we need to find Y. So what can I do? We can multiply both sides by A inverse. Both sides, let me multiply by A inverse. A inverse ABY is equal to A inverse E. You know what is A inverse E? That is A inverse. A inverse E, that is same as A inverse. And this A inverse A. And this is what? This will be E. So it will be BY equal to A inverse. So I got BY equal to A inverse. Now what you do? Now multiply by B inverse. Now multiply by B inverse. So from here I got Y equal to B inverse A inverse. That's it. Did you prove it? How many of you got this proof? Did you understand this proof? Okay. So very simple. So this is the idea. So in a group, prove that AB inverse is equal to B inverse A inverse. This is correct. Same idea you can do. Okay. So these are the some properties.